Welcome. Let's solve Leetcode 1769. Minimum number of operations to move all balls to each box. We're given n boxes. You're given a binary string boxes of length n, where boxes I is either the string 0 if the ith box is empty, or the string 1 if it contains one ball. In one operation, you can move one ball from a box to an adjacent box. Box I is adjacent to box J if the absolute value between their indices is 1. Note that after doing so, there may be more than one ball in some boxes. Return an array of size n where answer I is the minimum number of operations needed to move all the balls to the ith box. Each answer I is calculated considering the initial state of the boxes. Okay, so let's go over example 1. So we have boxes with this string here. So that indicates there's one ball in the first box, one ball in the second box, and 0 balls in the last box, in the third box. So for this first box, you'll have to move one ball from the second box to the first box in one operation. So that's one move. For the second box, you will have to move one box from the first box to the second box in one operation. So that's why the first two answers are 1 so far. The third box, you'll have to move one ball from the first box to the third box in 2 operations, and move one ball from the second box to the third box in 1 operation, which gives us a total of 3. And this is the expected return result, 1, 1, and 3. Okay, so I hope that makes sense. This other example is very similar to that one, so we don't really need to go over it. So let's go over how we'll solve this problem here. I think what we can use is a 2-pass approach. Let me see, so 2-pass approach, where the first pass will consider the balls we need to move to the right, and the second pass will consider the balls we need to move to the left. Okay, so that will be our approach. Okay, so let's consider this this example here. I've come up with an example. So let's first consider maybe moving to the right. So let's first consider moving to the right. So what we'll do is let's go over some things that I think will help us solve the problem. So let's just suppose there's only one ball and we're moving to the right. So if for our results, let's take this off real quick. Maybe like this. Okay, so our result in our first index, so we're gonna have there'll be four spaces for each of the indices that we need to account for. So looking at this first index, again, we're moving to the right. How many balls would need to be moved to the right? So in this case, there wouldn't need to be any balls moved to the right. Okay, next, let's also keep a total of how many balls, num of balls on the left side. And so initially it'll be 0, right? So initially it'll be 0, but now after this first index, now there's 1. So now we're right here. So let's suppose we're here. So now we're here. We're at index 1. So at index 1, now there's one ball. So we'd need to move one ball. So that'll be 1 here. Okay, moving on. Now we're at index 2. So there's still only one ball to the left. But notice now we need to consider how many steps would it take to move this one ball over there? Well, it would be 2. And over here, well, it would be 3 if we move to the last index. So let's go over one more thing here. Let's keep track of another variable, maybe. Moves. I'm gonna call it moves to right because it makes more sense to me. Okay. So let's change this example now. I'm gonna change this to 1 here, and I'm gonna add a 0 here, and we'll start here again. And let's clear this out. So let's set these all to 0 because we don't know the answer for now. So initially the number of balls to the left is 0, and moves to the right will be 0. So here, we don't need to move any balls to the right. It's impossible at this point. So this would be 0, and so this is 0. Now, once we move here though, we need to move here. But before we move though, we need to add the number of balls to the left. So here though, we know there's one ball to the left. Okay? And then that means before we move, we want to update our moves to the right. So our number of balls will always account, our moves to the right will always count for the balls to the left. So this will in essence be, in essence it'll be like a running total. Yeah, sure. So before we move, we need to update this balls to the right. So let's say moves to the right. So we'll say it's 1. Now let's go over here. So now we're here. So we'll use this moves to the right, and this we'll have to update this value here. So this will be 1 now. Okay? But now though, we need to update our balls to the left because now there's 2 balls. So then this becomes 2. This becomes 2. And now let's also update our moves to the right. See, because now we have to account for both of these balls as we move forward. So then this will be 2. Moves to the right. Actually, this would be, sorry, let me take it back. So because it's a running total, we're going to add the 2 to the 1. So then this becomes 3. Okay. So now when we move over here to the next index, so notice how we add this moves to the right. This is the value that goes here. Okay, so then this will be 3. Okay. Now does that make sense? So if we move this one ball to the right, that's one move. But then this first ball at the 0th index needs to move 2. So that's why it's 3 here. Now if you notice, well, I'll go over it at the end, but there should be a pattern that forms as we move forward. Now let's progress. So now we're here now. So sorry. We need to, before we move now, we need to update our balls to the left. There's still only 2 balls to the left, but we need to update our moves to the right because this is like a running total, so it needs to grow no matter what. Now, notice though, it grows by the number of balls to the left. It grows by the number of balls on the left. That's how this always grows. And does that make sense? Because each of those balls on the left has added a distance of itself to the moves to the right. I hope that makes sense. Let's go on to the next value here. So now we're at index 4. So then we say whatever's currently in our storage here for the result, that we'll add this moves to the right here, and that becomes 5. Okay, now before we move, we need to update our balls to the left. It doesn't change, there's still only 2 balls to the left. But our moves to the right. Well, remember these balls are getting farther. As we move to the right, these balls are getting farther. How much farther? Well, they're getting farther by the number of balls. That's it by itself. So the number of balls would be, well, so remember we add this to the number of balls these balls have each grown a distance of 1. So now this is 7. Now we move forward to here, and then we add whatever's in our result, we add whatever the move to the right is. So now this becomes 7. And we could update our balls to the left, but it's going to stay the same, and moves to the right would just, well, this would be 9. It wouldn't be too important because there isn't any, the list it has ended, so this is not really too important, but nevertheless, for sake of completeness, we have updated moves to right. Now, does this make sense that it would take 7 moves to get here? Well, let's count it. So this first ball, let me see, if we count 1, 2, 3, 4, and this other ball at index 1, that would move 1, 2, 3. So yes, this is correct. So I hope that makes sense. And then we would do the same exact thing for the right side. We would do something similar for it. So moving to the left. I'm actually not going to walk through it because it's very similar, but we would update. This would be something like number of balls on the right side and moves to the left, and we would, well, start at 0. Both these would start at 0, and then we would perform the same type of scenario we did here, but just in reverse. So we can initially we'll use 2 for loops, one that performs the right pass and the one that just utilizes a left pass, and then later on, if we want, we can try to merge them into one for loop. But let's just try to keep it simple for now, and we'll implement this as it is. Okay, I think that's enough to get started, so let us begin. Okay, so we'll get the length of our list here. So we'll say n equals length of b, and we'll create our result, and that'll be 0 times n. Okay, so we've initialized our result. Just to get out of the way, I'm just going to return the result before I forget. Now we'll say number to the left, and I'm going to say move to right, and this will be, we'll initialize them to 0. Okay, so let's create our for loop that conducts this operation. And so hopefully it makes sense why I'm doing it like this. So if our exam or problem is more complicated, like something like this, I don't know. So eventually what we'll have is we'll have our results. For example, we'll have our result for the right pass, and it'll be something like, I don't know, it'll be something like, something like that. And then we'll have our result for the left pass, and it'll be something like this. And then what we can do is we can add them together, and that would, like for example, we would need to move these 3 balls if we're considering this index here. We would need to move these balls to the left, and then these balls to the right, and we can add them and place them here. So that's what we'll be doing. Moving to the right and then moving to the left, and then we can just sum them up. Okay, so let's go over that here. So let's create our right pass first. So our right pass would be for I in range n, and then we'll update our results to handle what we have so far. So we want to handle the moves, so we say move to right, and initially it's 0, so it makes sense. We don't need to move. If we're starting at this first index here, there are no balls. There are no balls over here. This is the first index, so it should make sense. Okay, and now we need to update our other variables. So we can say, okay, what do we have? What do we call it? The number of balls on the left. And this will be what? So what we have here is our string can be a 1. So whatever this is, we can add that to our left count. This is the count of balls to the left. So it's a string currently. So if I say b of I, this is the string. So we need to convert it to an integer. And if this is 0, if it's a 0, it doesn't affect our update of left. But if it's a 1, it does. And then we need to update our moves to the right. So move to right. And this will be the number of balls here on the left. Okay, so what we'll do is maybe we'll print this out for every step. So we'll say print I, and we'll say maybe, let's say maybe sure I for the index, maybe num left, just so we get an example of how we are progressing, and move to right. And okay, just so we get an understanding of how we're doing. Okay. Okay, so let's look at this one. I think this is maybe a little bit more clear. So when we're here, we don't have any balls to move to the right. So all these are 0, 0. So notice though, once we get 0, 1, 2, yeah, so now we have 1 ball to the left at this point. So once we get to index 3, which is here, there has to be 1 ball that needs to be moved over. And same thing here. So notice how the moves to the right grows by the number of balls we have on the left. So here we have 1 ball, but that not only grows by itself, but at this point now we have 2 balls, so that it doubles, 4. And then since we're here, it actually did add 2 to itself, 6, but it also added this new ball, which made it 7. So we added 2 balls here. We also added 2 balls from this index to this index, but we actually added 1 more because at the current index there's also a ball. That's why this is a 7 here. So I hope that makes sense. Okay, and now let's perform our left pass. Actually, let's print out the result here, just so we can get a look at it. So the result here so far is 0, 0, 1, 2, 4. Now let's see if that makes sense. So let's make this a bit bigger. So these first 3 indices are 0 because we don't need to move any balls from the left, because there aren't any balls to the left. In this case, you can't move a ball to itself, so it doesn't make sense. We get our first result here at index 0, 1, 2, 3, because we're moving this 1 ball that we've seen to this index. And then once we get to this index 4, now this 1 ball is length 2 away, so it added itself here, so it gets 2. It becomes 2. And then notice here, at this index, how many balls are to the left? 2. And they've both grown a distance of itself, and that's why there's 4. So it takes 1 here, and then it takes 1, 2, 1, 2, 3. So that's why we get 4. Okay, so now let's do the same exact thing, but like a little bit inverted for the pass from the right to the left. Okay, so let's just do it. I guess we can do it like I'm trying to think if we want to do a separate for loop, but let's do a separate for loop. So we can say something like for I in range. So the last index would be n minus 1, okay? And then we say all the way to -1 here. Okay. And now let's update our, let's do basically the same thing here. We can actually copy this, but we need to modify it though. Well, a couple of things, we need to change these variables too, but we can do that pretty easily. So this will be the number on the right. In fact, let's do this here. Number on the right, and these will be moves to left. Move to left. Okay. Okay, everything's looking good so far, and I think that's about it. We can actually run it locally. Okay, looks good. Let's submit it. I think I will try combining this into a single for loop. So let's try that. So how do we do that? Okay, so we'll need these variables, so we'll move them to the top. And then we'll just remove this for loop portion. So now we need to calculate this. So we can't use I here, we need to use a different variable. So let's use maybe j. So j will equal what? It'll equal n minus I minus 1. And this will be, if we calculate it correctly, this would be the last index. So the total number of indices, wherever we're at, then minus 1. Okay. And then I think, oh, then we need to update our this part here. So this, wherever we're at a box here, or brackets, this becomes j. And I think everything else is the same. Let's test it locally. Okay, let's submit it. And I'm not sure it'll make too much of a difference because ironically it's slower, but because even if we did consolidate into a single for loop, the time complexity with 2 for loops, it would be just O of 2n, which is basically n, and here it's just 1 for loop and still O of n, so it doesn't make a difference. I'll just submit it one more time. Okay, so I hope you found this video helpful or educational. If you did, please consider liking or subscribing. Other than that, have a wonderful day. Take care of yourself.